Describe the operation of a Hall effect sensor and give an application. A Hall effect sensor uses a type of transduction known as the Hall effect to develop a voltage at right angles to the current flow in a conductor when subjected to a magnetic field. A typical Hall effect proximity sensor uses a DC power supply, detection circuit, and plate made of semiconductor material. Current flows through the semiconductor plate undisturbed when no magnetic field is present, which creates an even electrical charge across the plate and no output voltage to the detection circuit. When a magnet approaches the plate, the magnetic field detects current flow toward one side of the plate, creating an uneven electrical charge on the plate and a small output voltage to the detection circuit. The detection circuit senses this voltage and closes a switch that energizes the Hall effect sensor output. The plate charge returns to normal when the magnetic field leaves the material, causing the switch to open and turn off the sensor output. Any factor that affects a magnetic field can impact the performance of the Hall effect sensor. There are three main characteristics that can affect sensor performance: magnetic field strength and polarity, internal circuitry, and target material. Hall effect proximity sensors have strict requirements regarding the strength and polarity of the magnetic field required to operate the sensor. Many Hall effect sensors may even detect magnetic fields of only one polarity to avoid false triggering. Hall effect sensors generate very small internal voltages. Internal circuitry boosts these voltages to levels that may be used by other devices. Some sensors provide an analog output that varies with the strength of the detected magnetic field. A common example of this is a Hall effect current sensor. Digital sensor outputs simply turn on when detecting a magnetic field of sufficient strength. Hall effect sensors only detect objects that have a magnetic field. Non-magnetic objects require the use of a separate magnet attached to the object. Hall effect proximity sensors are used to detect a magnet mounted to an object and are mounted within a few millimeters of the object to be detected. Many hydraulic and pneumatic cylinders feature Hall effect sensors mounted at the cylinder ends, with a magnet mounted inside the cylinder housing on the cap end of the cylinder rod. These sensors provide a signal to a connected control device when the cylinder is fully extended or retracted. One application of a Hall effect sensor is the measurement of conveyor speed. The sensor detects each revolution of the conveyor using a magnet attached to a pulley and generates a pulse each time the pulley makes a complete turn. The speed of the conveyor determines the speed of the pulley, which in turn determines the rate of the pulses generated by the sensor. A separate instrument, usually a frequency counter, converts the pulses into usable units such as meters per second. A Hall effect sensor on a conveyor line cannot detect parts as they pass. What could be causing this? Describe